So, let us discuss the next question. Question number 10. A stone of 1 kg is thrown with a velocity 20 meter per second across the frozen surface of a lake and comes to rest. Okay, as we all know, when the temperature decreases, water become cool, and if the temperature still goes lower, the water becomes into ice. So here also same thing. The stone. Imagine a person is throwing a stone on the frozen surface of a lake. Okay, so this stone is thrown on the surface of the lake. And what is the mass of the stone here? Mass of the stone is 1 kg, 1 kilogram. Okay, thrown with a velocity 20 meter per second. So initially, the stone is thrown with the velocity 20 meter per second. Fine. Next, after that, it is very clearly mentioned that it comes to rest. So when it comes to rest, final velocity will become zero. V value is zero after traveling a distance of 50 meters. And not only that, it traveled the distance also, and the distance traveled is 50 meters. S is equals to 50 meters. And he's asking us to find force of friction between the stone and the ice. So when the stone is thrown, as we all know that friction acts between the surface of stone and the surface of the river or lake. Fine. So now he's asking to find frictional force F is equals to question mark. We know the formula for force, right? What is the formula for force? The force formula is F is equals to M into A. Okay. So already mass is given 1 kg, but acceleration is not given. Instead of acceleration, he has given us u value, v value, and s value. So which formula we can use to find? We can use the formula as we all know that v square minus u square is equals to 2as. Okay. Third equation of motion. As we have already discussed in first chapter, v square minus u square is equals to 2as. Now substitute all the given values here. So v value is given 0. So the whole value becomes 0. So 0 square or 0 minus u square. So 20 whole square. 20 whole square becomes 400. Okay, I'm directly writing the value here. 400 is equals to 2 into 2 into a. We do not know the a value, so we have to find out a value. And what about the distance? Distance is given 50 meters. So in place of s, I'll write 50. So 2 into a into 50. So 25 is 100, right? So finally, how much you will get here? Minus 400. I'll write the step again. Minus 400, which is equals to 2as. 2 into a into 50. 50 to the 100. So you will be getting here 100 a. Acceleration 100 a. Two zeros get cancelled here. So what is the remaining value? A. A is equals to minus 4 meter per second square. So this is the acceleration value. And now you substitute this value in the formula. What is the formula? We need to find force, right? The force formula F is equals to M into A. In place of M, already mass is given 1 kg. So I'll write 1 here into what is the acceleration? Minus 4. So minus 4 meter per second square, which is equals to minus 4, 1 4 is 4, minus 4 Newton. So therefore, force of friction is equals to minus 4 Newton. So this minus represent that force is acting in opposite direction of the motion of the body. Okay, because here the person is throwing the stone on the frozen lake. So the stone goes forward direction and frictional force acts in the opposite direction. So this frictional force which is acting between the surface of stone and the lake is minus 4 Newton. This is the answer for the 10th question. Please note it down. Coming to the next question. A 8,000 kg engine pulls a train of 5 wagons, each of 2,000 kg, along a horizontal track. Okay, so let us understand the question. 8,000 kg engine. So let us consider this is a train. Okay, and this is the engine of the train. Let us consider this is the engine of the train. Okay, what is the mass of the engine? Mass of the engine is given 8,000 kg. Mass of the engine is given as 8,000 kilogram. And not only that, this train is pulling five more wagons. Wagons are nothing but the boxes. Okay, five more wagons. So one, two, let us consider two, three, okay, four, and also one more left, five. Okay, so this train is pulling total five wagons, each of how much? Each of 2,000 kilogram, each of 2,000 kg. So this is these are the wagons. Okay, wagons are nothing but the boxes where we sit. And engine you already know it. So each of 5,000, 2,000. Then what about the total five wagons mass will become 5 into 2,000, which is equals to 10,000 kg. Okay, 10,000 kilogram is the total mass of the wagons. Okay, fine. And total, if I ask whole mass of the train, it will be 18,000 kilograms. Okay, that you have to keep in your mind. And if the engine exert a force of 40,000, the engine is pulling towards this direction. What it is pulling? It is pulling the remaining four wagons, five boxes. Sorry, five boxes. And how much force? Force is equals to 40,000 newtons. It is applying 40,000 Newton force. 40,000 Newton force. And track offers the friction force of 5,000 Newton. We know that railway track. Okay, let us consider this red color. This red color one is a track. So train is going forward in this direction. Then friction will act between the track and the train tire. Okay. Now the opposite force, friction always acts in the opposite direction, right? So which is equals to how much? 5,000 Newton. It is given as 5,000 frictional force, small f, is equals to 5,000 Newton, which is acting in the opposite direction of the motion of the train. Now, what is he asking? He's asking to calculate the net accelerating force. Okay, he's asking us to find the net accelerating force. So, what will be the next net accelerating force? So, note down net accelerating force. First one, we need to find out. First, we write the given values. Okay, I'll write the given values before finding it. Given. Okay, every time you should write in this way only. Even in exam also, for writing given values, you get a half mark. Given mass of train equals to how much kg? Sorry, mass of engine is equals to 8,000 kilogram. And wagons of 2,000 kg each. So total, how many wagons are there? Five. So 5 into 2,000, which is equals to 10,000 kilogram, will be the mass of wagon. So here I write mass of wagons. Okay. So this will be the second point. First one, mass of the engine. Second one, mass of the total five wagons. Okay. Now, note down. Third one, also given force exerted by engine. Force of engine is equals to 40,000 newtons. Okay. And frictional force is equals to 5,000 Newton. Okay, understood. Now, what is he asking? He's asking to find net accelerating force. First, let us find net accelerating force. What will be the net accelerating force? Acceleration. See, train is going in the forward direction and friction act in the opposite direction. So, what will be the total net acceleration? Net acceleration will be 40,000 minus 5,000 newtons, which is equals to 35,000 newtons. Why I'm subtracting 5,000? Because friction always acts in the direction of the motion of the body. So first answer will be 35,000 newtons. Okay, let us come to the second one. Secondly, he is asking, what is he asking? He is asking to find the acceleration of the train and also he's asking to find the force of wagon 1 on force of wagon 2. Okay. So what will be the acceleration of train? We need to find acceleration of train. Okay. So A is equals to, but we know that. Okay. We know that. What is the formula? Force is equals to mass into acceleration. Okay. With this, we can find out A is equals to, what is the A value? A is equals to F divided by M. So using this formula, you can easily find out. Now, what about the mass? Okay, we know the force. Okay, what is the total force acting by the train net accelerating force? 35,000. So F value, we know that we have to exclude frictional force. We know that capital F, this capital F, A is equals to F by M formula. In that formula, capital F is equals to 35,000 Newton, and mass we need to find the mass of train. Okay, what will be the mass of train? Mass of train is equal. So I told you in the beginning itself. Mass of engine is 8,000. Okay, but there is not only engine. Along with the engine, there are again 5 wagons were included. So total will be 18,000. Okay, 18,000. How you are getting 18,000 kg? Engine 8,000 plus 5 wagons were there. So total 10 plus 8, 18,000 kg. Now substitute in the formula. A is equals to F. What is the F value? 35,000 Newton divided by 18,000 kg. Okay, and divide these two values. These 18 by 35. So if you divide it, you'll get almost 1.944 meter per second square. Okay, this is S to the power of 2 meter per. Right here. Okay, so this is the acceleration of the train. Hope it is clear, right? Now we need to find the final one and the force of wagon 1 on wagon 2. It is very important. Okay, he's asking to find, so there are how many wagons are there? There are total 4, excluding engine. So total 5. 5 are there. 1, 2, 3, 5, 3, 4, 4, and I'll draw here 5. 5 wagons. Now he's asking, what is the force of wagon 1 on wagon 2? What is the force? This is first one, second one, third one, fourth and fifth wagon. Total 5 boxes. What is the force of first one on wagon 2? Okay. So now we need to find out the force of. Okay. So note it down. C, we need to calculate C value. C of the force of wagon 1 on wagon 2 is okay. So first we write force. What is the force formula? F is equals to, okay, is question mark. Is question mark. We need to find the formula. We know that F is equals to ma. Okay, we know that F is equals to m into A. With this formula, we have to find out the force of wagon 1 and wagon 2. Okay, so here you need to understand what is the force value? 35,000, right? Net force 35,000 is equals to, what is the mass of the wagon? Here, see, total how many wagons are there? 5, right? So out of 5 wagons, we need to calculate the net force. Okay, net force. First, we see the total mass of the wagons. What is the total mass of wagon? 10,000. Okay, 10,000. Here, 10,000. Okay. See, first to find the force, we should know the mass and acceleration. Okay, mass and acceleration. But we do not know acceleration here because it did not give acceleration. So then A value, what will be A value? Mass is 10,000, including total 5 wagons. So I will not take engine because he is not asking about engine here. Okay, he did not mention. So wagons. So total wagons are 5. So 10,000. So therefore, with this 30, A is equals to 35,000 divided by 10,000. So what will be the answer? 3.5 meter per second square. You will be getting 3.5 meter per second square. So this is the acceleration of acceleration, acceleration. Okay, and now, okay, this is the acceleration of the wagons. Okay, acceleration of wagons. Now, what we have to find? We have to find force of wagon on wagon two. Okay, so what will be the answer? F is equals to, I'll write R else you can write F1 is equals to, okay, force of wagon one and wagon two. Now tell me how many wagons are there? There are five, right? But now here we need to take only four wagons, because wagon one force we need to find out how much it is acting on wagon two. So from wagon two onwards, if you count, there will be remaining four only. So force formula F equals to ma. So then mass, I'll write formula, then I'll write the answer. Therefore, F is equals to F1. F1 means force of wagon 1 is equals to 8,000. 8,000 into what is the acceleration value? 3.5. Okay, so 3.5. So how much you'll get? 8 into 3.5, almost you'll be getting 28,000 newtons will be the answer for options. Okay, so I hope it is clear. Okay, if you have any doubts, again, you can ask me in comment box so that I can clarify. Simplify it. Okay, fine. Now let us go to the next question. We have almost we completed 11 till 11. Okay, right. This is very simple one, 12th one. An automobile vehicle has a mass. Imagine this is a automobile or vehicle. Okay, it's a vehicle or bus or something, whatever it is. Mass of this body is given. I'm explaining 12th answer. Mass of the body is 15,000, 1500 kg. Okay, 1500 kg. Mass is given. What must be the force between the vehicle and road if the vehicle stopped with a negative acceleration 1.7 meter per second square? He's asking what must be the force. It means he's asking what is the force value if the vehicle stop, when the person applies, when the driver applies the brake, vehicle will stop, right? With negative acceleration. So acceleration negative, I'll take A is equals to, this is A. A is equals to minus 1.7 meter per second square. Minus 1.7 meter per second square. And we know the formula. What is the formula to find force? Force is equals to mass into acceleration. So substitute all the values here. So M value is 1500. So 1500 into minus. So I'll do one thing. I'll write. Okay. First, I'll write minus of 1500 into here 1.7 is there. So already I have written minus here. 1.7 can be written as 17 by 10. 17 divided by 10. So 0 get cancelled. So if you multiply 17 into 150, 17 into 150. So you will be getting the answer. You will get the answer minus 2,500. 2,550, and it is a force, so unit will be Newton. 2 minus 2,550 Newton, 50 is the answer for 12th one. Okay. Now let us see the 13th one is a MCQ type question. What is the momentum? We know momentum. Momentum is nothing but product of mass into velocity. Product of mass and velocity. And momentum is denoted with letter M. And if the mass is m and velocity is v, so what is the momentum? We know momentum will be m into v. Option D is the correct answer for 13th one. Okay, let us discuss the next question, 14th one. So 14th one is a direct question. Using a horizontal force of 200 newtons. Okay, let us consider that this is a body. Okay, wooden cabinet. Okay, 200 newton, using a force of 200 newton. We intend to move a wooden cabinet across a floor at constant velocity. Okay, so if at all this is imagine the wooden block is placed on the floor. Okay, the brown color one is the floor, and now we are applying how much force? We are applying here 400 newton force. This side force is equals to 200 newton. Let us consider force is equals to 200 newton. We intend to move. We are trying to move it. Okay. What wooden cabinet? Let us consider this as a wooden cabinet. Across a floor at a constant velocity. Velocity is constant. What is the friction that will be exerted on the cabinet? He is asking what is the friction. So friction will act in opposite direction. Right? What is the friction will act in the opposite direction. Okay. See here, if they answer, what will be the, what is the, he's saying velocity is constant velocity. Okay, so velocity is not changing. Okay, if constant velocity, so the answer will be, I'll write here. It's not a numerical to solve here. Answer will be here. If you see in this case here, net force is zero. Why net force is zero? Tell me. Because velocity is constant. Okay. So here net force is zero because the cabinet because the cabinet will move with a constant velocity. So the answer is 14. Okay. Yeah. Fine. Let us go to the next question. According to Newton's third law of motion, when we push an object, the object also pushes back us with an equal and opposite force. Yes, it is, we know already. Newton's third law. If the object is a massive truck parked along the roadside, it probably not move. Yes, if massive truck is parked, and if we try to push it, it won't move because the mass is huge. Okay, and too heavy. It will probably not move. A student justifies this by answering that the two opposite and equal forces cancel each other. Comment on this logic and explain why the truck does not move. Suppose if a student is standing here, imagine, and he is trying to push it. Will it move? It won't move because the mass of truck is more than the force applied by the body by the person. So it won't move. And two forces will get cancelled. What are those forces? One is force of the person on the truck and truck force on the person. Okay. And also we should consider the tires also. Frictional force as well. Friction force will act between the truck tire and the road. Okay. So what could be the answer? So I'm writing the answer here. This is 15th answer. Okay. You may note down. Action and reaction. Okay. Action and reaction. So who is giving action here? Person. Person. What action is doing? He is doing pushing the board, pushing the truck. Okay. And what about reaction? Reaction by the truck on the person. Action and reaction always act on always act on different bodies. Okay. It is very important one. Action and reaction won't act on the same bodies. Different bodies. What are the different bodies here? Person and the truck. Okay. So they cannot cancel each other, each other. So each other. So when we push a massive truck, the force of friction between. Okay, this is very important. The force of friction between what? Friction between its tires and road is very large, and and so the truck does not move. Okay, so two forces will cancel. Friction between the tire and the road. That is the reason the body will not move. Okay, these are the two opposite forces. The force is applied force in one direction. Reaction force by the tire in opposite direction. The frictional force. So both get cancel each other and truck won't move. Okay, so this is the answer for 15th question. Okay, so hope you have understood. Let us discuss the remaining questions in the next video. Okay, thank you.